All right, today we're diving into something huge. We're talking about the future of literally every device you own, and the invisible atomic-level threat that could bring the entire tech industry grinding to a halt.
And that's not an exaggeration at all. Think about your phone, your car, the cloud, all the AI that's coming. Every bit of it depends on us making microchips smaller, faster, and more powerful. But that future is now up against an enemy so tiny, it exists on the atomic scale. So to really get a handle on this threat, we first have to meet the hero of our story, a pretty stunning new technology called Gate-All-Around, or GAA for short. Now, GAA isn't just some small upgrade. It is a complete redesign of the transistor, which, as you know, is the fundamental building block of all electronics. This is the engine that's really going to power the next decade of technology. And frankly, it's our best shot at keeping the famous Moore's Law alive and kicking. So why is GAA such a big deal? Well, let's compare it to the current champion, FinFET, which is the tech inside most high-end chips today. FinFET has been an absolute workhorse, but it's hitting a physical wall. GAA, by literally wrapping the gate completely around the channel, gives chipmakers this unprecedented control over the flow of electrons. This means drastically less power leakage and the ability to build transistors that are just mind-bogglingly small and efficient. It's a true generational leap for sure. But here's the twist in the story. This incredible new power, it comes with a profound new vulnerability. And this is where our invisible enemy makes its entrance. I mean, it sounds almost too good to be true, doesn't it? There's gotta be a catch. And the catch is its own beautiful design. The very thing that makes GAA so powerful, these super thin layers called nanosheets, are unbelievably fragile. A single stray atom from the air in the factory can act like a wrench in the gears, grinding the entire system to a halt. And the damage from these tiny defects? It's catastrophic. We are not talking about a small glitch here. As you can see, these little impurities lead to slower chips, devices that just drain your battery, and a devastating loss in manufacturing yield, which means billions of dollars in wasted silicon. They can even cause products to fail months after you've already bought them. The stakes are just immense. So how do you fight an enemy you can't even see? Well, you don't. You create an environment of absolute purity, a battlefield where the enemy literally cannot exist. And the experts have zeroed in on this. Building these delicate chips inside an ultra-high vacuum, or UHV, is the most promising way to get this done. The logic is actually pretty simple, but it's so powerful. By building the chip inside a chamber that is as close to a perfect vacuum as we can possibly get, you starve the enemy. There are virtually no stray atoms or molecules that can land on the chip's surface and cause a defect. You just eliminate the threat before it even has a chance to start. So how does this actually work in practice? This part is fascinating. UHV is integrated into the absolute most critical manufacturing steps. It's kind of like having a series of surgically clean rooms all nested inside one another. First, you've got the nanosheet growth. That's like laying the impossibly thin foundation. Then, you integrate the gate, the part that switches it all on and off. Next, you perfect all those super important connection points. And finally, you apply a protective coating. Every single one of these steps happens inside this pristine vacuum, making sure those delicate structures are perfectly shielded from start to finish. Solving this incredible engineering challenge is one thing, but this breakthrough has absolutely staggering financial consequences for the entire tech industry. We are talking about a multi-billion-dollar payoff. By using UHV to build these atomically perfect chips, manufacturers see immediate massive gains. They get more working chips from every single super expensive silicon wafer. They can sort those chips into higher performance, higher profit categories, and they can deliver more reliable products to market way faster. In this cutthroat industry, that is a total game-changing advantage. And to put that advantage in perspective, just consider this number, 1%.
A 1% increase in manufacturing yield, I know, it might not sound like much, but for a major chip company, that single percentage point can translate directly into billions of dollars of additional revenue every single year. That's the just mind-blowing scale we are operating on. So what does conquering this atomic-level threat really mean for the bigger picture? It means the future of technology isn't just secure, it's atomic.
Look, Moore's Law isn't dead. It's just entered a new, incredibly challenging phase.
By developing these radical solutions like UHV processing to control matter at its most fundamental level, we're not just paving the way for the next generation of innovation, we are building the road to a future we can't even really imagine yet. And that leaves us with a fascinating final question, right? We're learning to defeat these atomic level impurities. But as we push our technology deeper and deeper into the quantum realm, what other invisible giants are just waiting for us out there? What new physics will we have to master? The only thing we know for sure is that the next revolution is already quietly beginning.